Okay, so today we'll be discussing some questions from week 6. So the first question is, this is the first question. I want you guys to give this one a try and then we'll do this in the class. Anyone done with the question? Are you guys trying? Am I audible?
Yes, ma'am, you're audible.
Okay. So I hope you guys are trying this. We'll do this once we see some answers. Just drop your answers in the chat box. Okay, so let's see how we solve this question. So this one is, you've been given the value of natural log of x minus natural log of y, which is a. This implies that your x natural log of x by y should be equal to a. And similarly, your natural log of, just 1 second. Yeah, so similarly, you will have natural log of y by z is equals to b, and natural log of z by x is equals to c. And then this will give you x by y is equals to e to the power a. So we're taking this, both of these to the power a, raise this to the power e and raise this to the power e. So you'll get this thing. Same we do here, we'll get y by z is equals to e to the power b. The property that we've used here is, if log base e x is equals to y, this implies e to the power log base e x is equals to e to the power y, which implies x is equals to e to the power y. This is what we've used here. Similarly, we'll get this, and here we'll get z by x is equals to e to the power c. And we have to find the value of x by y to the power b minus c, c minus a, and a minus b are the exponents. And here you have y by z and z by x. So this will be equal to e to the power a times b minus c, or e to the power a raised to power b minus c, multiplied with e to the power b raised to the power c minus a, and e to the power c raised to the power a minus b. We've just substituted these values from here. So you will have e to the power ab minus ac, and there you will have e to the power bc minus ba, and there you will have e to the power ca minus cb. So this is going to be equal to e to the power, and how do you multiply these things? So you just add the powers, right? So you'll have AB minus BC minus AB AC plus BC minus BA plus CA minus CB. So this is going to give you these two get cancelled, then these two get cancelled, and these two get cancelled. So you'll get e to the power 0, which is 1. So the answer to this will be 1. Is this one fine with all? Can we move to the next question?
Yes, ma'am.
Okay. So this is the next question. Give this one a try.
Hello, I'm not able to hear.
Yeah, because I was not speaking. I wanted you guys to try this question. Now we'll do this here. So the question is, you have been given that at time t or at t hours, the bacteria culture grows. The growth of bacteria culture is this. So that means, and then next you've been given some data, which is at t is equals to 2 hours. I'm avoiding the unit here. T is in units. So at t is equals to 2 hours, you have P is equals to 3 times the initial population. So let's first find the initial population. For initial population, this is your time t. For initial population, you put t is equals to 0. So you put t is equals to 0 here. This is going to give you, for initial population is the population at t is equals to 0. So when you put t is equals to 0, your p of 0 will be a e to the power 0t, which is just a. And this says that at 2 hours, your population becomes, so P of 2, that means at time t is equals to 2 hours, your population becomes 3 times of the initial population. So initial population is A and 3 times of it will be 3A. And at t is equals to this capital T, let me just say that now I've taken capital T time. Then at this, your population becomes 81 times of the initial population. So this is the data given to you. And you have to find the value of T, this capital T. So if your P2 is equals to 3A, That means P2 is A e to the power 2k. This is given to be 3 times A, right? And Pt will be A e to the power 2 tk. This is given to be 81A. This implies that your e to the power 2k is 3, and this implies e to the power tk is 81. You have to find the value of t. So from here you'll have t is equals to natural log of 81. I'm applying natural log on both sides. So I'll have natural log here and natural log here. So this will give me just tk. On left hand side, I'll have tk, and on the right hand side, I'll have natural log of 81. Because natural log of e to the power tk is just tk, right? So this would mean that my t is equals to natural log of 81 by k. But I don't know what k is. K is also an arbitrary thing. So we'll have to find that.
K equals to log 3 by 2.
Yeah. So from this equation, we'll use this equation to find the value of k. So this implies that my 2k is equals to natural log of 3. That means my k is, or I simply can write from here, k is natural log of 3 by 2. This means my t, now I'll put the value of k from here in this equation. I'll get t is equals to natural log of 81 divided by natural log of 3 by 2. So this will be 2 times this. And this is 2. Natural log of 81 is just natural log of 3 to the power 4 by natural log of 3. This thing, this will come forward. So this will be 8 natural log of 3 by natural log of 3, which is just 8. So 8 is our answer. Is this okay? Can we move to the next question?
Yes, ma'am.
Okay.
Ma'am?
Yeah.
Ma'am, I have to ask that is there any difference between at 2 hours and after 2 hours?
No, that, see, there's not, in such questions, there's no difference at 2 hours, after 2 hours. It's the same thing. Because
Okay.
you obviously that, okay. So this is the next question. The question's visible, right? It's not too, the font is not
Yes,
too small,
it's
right?
visible.
So this is the question. Give this one a try.
Okay, ma'am.
Ma'am, the answer is first option.
Okay, so let's see this one. To solve this question, you will need things in firstly, whenever you have something like this, it's always ideal to have this in the argument and this as the base. So we'll interchange these things first. This expression of ours will become 4 log x log base x b plus 9 times log b, or 1 by log base b to the power 5x, right? And this should be equal to 1. And then from here we'll have 9 by log base b to the power 5, and plus log base b log base b x. This will be 1, right? And this is log x b here 4 times. 1 second. This will just be 5. So this is the properties that we're using here. Is here we have used the property that log of base a b is the same as 1 by log base b a. And here we have used the property that log of xy is the same as log of x plus log of y. And this will become 4. And let me just say that I'm taking this thing to be, because I don't want to keep writing this. I'll take this as t. So this is t. This will be 9 by this entire thing is 1, right? Sorry, 5. This becomes 5 because log base x to the power 5 or x to the power n in general is just n, right? This will be 5 plus log base bx, but I can write this as 1 by log base xb. So this will just be, and this is t, right? I've taken this thing to be t. So I'll replace this with a t. So I'll have 5 plus 1 by t. And then we just have to solve this equation. So this is an equation in t. I have to solve this. This will be 5t plus 1, 9t. And there you have 4t is equals to 1, which is the equation will be 20t square plus 4t plus 9t. So that's great. Yeah, 4t plus 9t. We'll have 13t, and this will be 5t plus 1 is equals to 1. So on that side, you'll have 5t plus 1. And this will give us 20t square minus 8t plus 8t minus 1 equals 0, right? So now this is just a quadratic equation. So if we'll solve it, we'll have minus 8 plus minus b square 64 minus 4ac, 4, 20, and minus 1. So this is going to give us plus 80. Plus 80 divided by 40. So our t is going to be equal to, just 1 second. Yeah, so this is t. There are two values of t. T is equals to -8 plus, and this is 144. So square root of 144 then is 12 by 40, and -8 minus 12 by 40. So this is 1 by 10, and this is minus half. So these are the two values for t. Then, and our t was log base, was it x or was it b? Log base x b. This was our t, and b is given to be greater than 0, right? So what will be x then? So x in terms of t will become, because we already have the value of t, we have to find x, right? The question is about the values of x. So we'll have x is equals to, or you can say, from here you will have x to the power t is equals to b, or you can, in other words, you can write this as x is equals to b to the power 1 by t, right? This gives us x to the power t is equals to b. I've written it in this manner. X is equals to b to the power 1 by t. So that means, and b for b greater than 0. So you can choose b to be greater than 0. And what's t? So what are the possible values of x? Because the possible values for t are 1 by 10 and minus half. So for x, the possible values become b to the power 10 and b to the power minus 2, right? So, and then from the options, I have to check which of the options are of the form b to the power 10 or b to the power minus 2, where b is a number greater than 0. Is that okay? So let's check that. We have b to the power 10 and b to the power minus 2. So this is clearly of the form. Yeah,
Yes, no option is correct.
okay. So this is correct because this is clearly of the form b to the power 10, where b is equals to 6 and 6 is greater than 0. So that's fine. Then this one, 6 to the power 9. So I can write this as 6 to the power 9 by 10 to the power 10, right? This is fine. And this number is, I can consider this to be b, and this is greater than 0, right? 6 to the power 9 by 10 is greater than 0.
Yes,
So
ma'am.
that means this option is also correct.
B is also
Then
correct, right?
coming to this one, this is of the form minus, so you can write this as 6 to the power minus 5 by 2, or you can write this as 5 by 2, and here you can have minus 2.
Yes.
So that means this is also correct, where this is of the form b to the power minus 2. This is of the form b to the power 10. This is also correct. Then coming to this one, in a similar way, I can write this as 6 to the power 5 by 10 whole to the power 10. So this is also correct. Is this okay?
Yes, ma'am.
Okay, that means all options are correct here for this one. Can we move to the next question if this question is clear?
Yes, ma'am.
Okay. This is the next question. Try this one. And if anyone has a doubt in any question so far, we can discuss that too.
Ma'am, what's the answer?
I think
The
I think
answer
it's five.
is 5. It's 5.
Yes, ma'am, it's correct. Yes, ma'am.
So for this one, first is a usual way to use the definition of domain of FOG, and this is composition of more than one function. So the composition has been done 3 times if you see carefully here, and then we've added things too. So it's better for us to just simply for these kind of functions, all that you need to make sure of is first thing is that if you have something in log, then that value should be greater than 0. That means if this is in log, then this should be greater than 0. If this entire thing is in log, this is also in log. So this entire thing should be greater than 0. And second thing is if there's any other function involved whose domain you know is not real numbers, then you have to find that too. You have to find the values of x such that that function is valid on those values. You have to find those values too. Let's, for example, say if instead of this one, if you had 1 by x square minus 4 log base 2, then you would need to make sure that we exclude x is equals to plus minus 2 from the domain. So coming to this one, so for this one, what you need to do is first you need to make sure that x square minus 5x plus 8 should be greater than 0, right? Because for the domain of this is the innermost function, you start from here. So our idea is the innermost function, actually the innermost function is this one, this x square minus 5x plus 8, but it's valid for all x. So we don't have to find the domain of this one because the domain for this one will be all real numbers. Then we come to the domain that this one. So the values of x such that this thing is in the domain of log base 2 function, and then the values of x such that this entire thing is in the domain of log base 2 function. So for that, we simply find the values of x such that x square minus 5x plus 8 is strictly greater than 0. So this will give us, what are the roots of this? So the roots
Ma'am,
of,
actually, it's always positive. X square minus 5x plus 8. Because a is greater than 0 and d is less than 0, so it's always positive.
okay. So this will be, if you write this, okay, this can be written as x square minus 5x. So I can have 10x, 10, not 10 here, 5 by 2 square, and this can be written as 2 times 5 by 2, right? So this will be 5 by 2 square here. Adding this and subtracting this thing from here. So this will give us, this expression is the same as this one. This I want to be greater than 0. And this is x square minus 5x plus this entire thing is just x minus 5 by 2 whole squared. X minus 5 by 2 whole squared. And then we have 8 minus 25 by 4, which is this value is less than 8, right? It's right. This quantity is greater than 0, and this is also greater than 0. This is a squared quantity. You have other ways too to find this. If you don't want to do it this way, you can find the roots of this. So this will be, and then you can plot the parabola and see where it's positive, where it's negative. You can do those things too. That's fine too. But I'm doing it this way. So if you do it this way, you will have this expression is the same as this expression. And this is the square, so it's always going to be greater than 0. And this is 8 minus 25 by 4, which is 32 minus 25 by 4, which is 7 by 4. So this is also greater than 0. and this is also greater than 0. So the sum is also greater than 0 always. That means this value is always greater than 0, right? This entire expression will remain greater than 0 no matter what value of x you choose. That means we don't have a problem. We don't have any x excluded in this one. So this one is not causing any problem. Then we come to the next one, which is this entire thing. So for this one, now we'll have to make sure that 1 minus log base 2, and this was x square minus 5x plus 8. We want this expression to be greater than 0. For me to be able to apply log base 2 to this expression. If I want to apply log base 2, I want this to be greater than 0, right? That's why we're doing this thing. So if I want this greater than 0, I'll have minus log base 2 x square minus 5x plus 8 greater than, you will have a minus 1 here, and this will change the sign. So you'll have, I'm removing minus from both sides. The sign also changes. So if you have minus a greater than minus b, then a is less than b, right? So we have used that property here. And then we can raise this to the power, we can raise this to 2 and raise this to 2. So you'll have 2 to the power 1 here and 2 to the power log base 2 and this entire expression. So you'll just have this expression left, right? X square minus 5x plus 8 left on this side. And this is 2 to the power 1. So this is just 2. So when you do this, one thing that you need to make sure is here you have log base 2, because you have log base 2, some expression here less than 1. So what I can do is I can raise both of these to the power 2. But if instead I had 0.2 here, let's say I had 0.2 here or half here, something less than 1. If my base was between 0 and 1, then this sign will get changed. That means if I do this, let's say I have x square here, then this will become x square log half to the power 1. And this sign will change. So when you have base between 0 and 1, your sign changes, inequality changes when you're removing this. And when you have something greater than 1, then this inequality remains same. Is this okay? So in simple words, if I have to write this, I'll write this as log base ax if is less than log base ay. Then we have two conditions. X less than y if a is greater than 1, and x greater than y if a is between 0 and 1. So we're using this one, and this is going to give you, and because, okay, let's see where this thing is. You will have x square minus 5x plus 6 less than 0. And this thing simply is, you will split this into minus 2x and minus 3x. So we'll have x minus 2 and x minus 3, right? So this becomes x square, or I can write this expression as, by factorization, I can write this as x minus 3 and x minus 2. That means I want this thing to be, so what we're doing here is we're trying to find the value of x such that this expression is greater than 0. Values of x such that this expression is greater than 0, and all these are equivalent. So we're left with values of x such that this expression is less than 0. So when is this? So for this to be less than 0, I'd want either this to be positive, this to be negative, or this to be negative, this to be positive, which will give me, if I'll go by this one, I'll have x minus 3 less than 0, greater than 0. So I'll have x greater than 3. And from this one, I'll have x less than 2. So x greater than 3, less than 2 is not, you don't have any x which is greater than 3 and less than 2 both. So this has no solution from here. And from here you will have x greater than 2 and x less than 3. So this will be, x will belong to 2, 3. Right? And 2 and 3 are not included because you want this to be, we have a strict inequality here. So this should not be equal to 0. Why is it so? Because we don't want this to be equal to 0. If this thing becomes 0, then I can't apply log to it. Right? So by this will come out to be x belonging to the interval 2, 3. So that means my domain is 2, 3. There's no other condition left. We've checked both the conditions. First condition is when we have, first one was when this is greater than 0, this is what you have to check. Second one was when this entire expression, the second log one, argument of the outer log, this is greater than 0. So we have checked both of them, which gives us this. So this is our domain. And the question was to find a plus b if this is the domain. So if this is equals to a, b, then a plus b becomes 5. Okay. Can we move to the next question?
Yes, ma'am.
So this is the next question. Give this one a try.
Okay, ma'am.
Option A, ma'am.
Okay, let's see which one of these is correct. So the domain for you to find the domain of this thing, our aim is, let's say this is, I'm considering f is already given, and let me just consider the function gx to be natural log of x square minus 1. Then the domain of f o g, this is what we're looking for. This becomes domain of g, so this function intersected with x such that domain of g or g of x is in domain of f, right? And domain of f is given to be 0, 4. So I can replace this thing with 0, 4 interval. This is what I have to find. What's the domain of g? Domain of g is, your g is natural log of x square minus 1. So for that, you will need x square minus 1 to be greater than, strictly greater than 0, right? That means you want x square to be greater than 1. So this is when x is either less than minus 1 or when x is greater than 1, right? So this will be from minus infinity to minus 1. My x can belong to minus infinity to minus 1 or this interval 1 to infinity, right? This is the domain of G. Then coming to the other part, which is this one. I want to find the all the x values such that gx lies between 0 and 4 in this interval, right? 0 to 4. So this will be, I want x such that gx lies between, gx is strictly greater than 0 and strictly less than 4. So this is x such that natural log of x square minus 1 is strictly greater than 0, strictly less than 4, which is the same as x. And because this is log base e is greater than 1, and we've already discussed this, when base is greater than 1, you can directly take natural log, you can directly raise these to the power. So this will become e to the power 0. This will become e to the power natural log. So this will just be, this is e to the power natural log x square minus 1. And this will be e to the power 4, right? So this will be x such that this happens. This will be x such that this is just x square minus 1. This is 1. This is x square minus 1. And this is e to the power 4. So you want x square minus 1 to be between 1 and e to the power 4. Now, if I'll solve this further, I'll have x square between, you add minus 1 here. So I can add 1 on all these, 1 here, 1 here, and 1 here. So I'll get 2 here, x square here, and plus 1 here, right? And this will be the same as, so your x square is greater than 2. That means if your x square is greater than 2, that means your x is also greater than root 2, right? Or you can say not x square, this x square is either greater than root 2, or you should say your x is less than root 2, right? If you solve this equation, this inequality, this is not an equation. If we'll solve this, I want x square to be greater than 2. So if this confuses you, you can have x square minus 2 greater than 0, and this will give you x minus root 2, and this is x plus root 2, right? And then you want this to be, because you want this to be greater than 0, so either both positive or both negative. So this will be x greater than root 2 and x greater than minus root 2, or x less than minus s less than root 2 and x less than minus root 2. So these are going to give you two situations. This is going to lead to x greater than root 2, and this is going to lead to x less than minus root 2. So this means this is the same as x greater than root 2 or x less than minus root 2. So this gives us x belongs to the interval minus infinity to minus root 2 union root 2 to infinity. This one, and then because this is okay, instead, because you're solving them separately, I've solved this one first and then I'm going to solve this one. So you can write this as this one and x square less than e to the power 4 plus 1. So this interval will then become, we have solved for this one first when x square is greater than 2, and the second one will be when x square is less than e to the power 4 plus 1. So when this happens, you can solve it in the similar way that as we've done here, and you will get x between e to the power 4 plus 1 square root and e to the power 4 plus 1 square root negative. You will get x between these two values if you will solve this equation the same way as this one. Right. So, and if you want to just make a quick note of this, if your x square is less than k, then your x is between root k, minus root k and root k. And if your x square is greater than k, then this is when x is from minus infinity to root k and minus root k. And this is root k to infinity. So basically, when you have root k, minus root k here, root k here, if you have x from minus infinity here or here, you will have x square greater than k, obviously. And if you will have x here in this interval, in the red one, then you will have x square less than k. Is this okay? This is for x square less than k, and these ones are for x square greater than k, x square greater than k, both sides. So here we have solved this one. And because we want both of these conditions to be true, that means this interval becomes the intersection of these two. That means you will have what is this interval? This means your x should be from minus root e to the power 4 plus 1 to root e to the power 4 plus 1. So this is one interval and the other interval was this, right? And because I want x to belong to both of these, this set 2 and this set 2, that means x should be in the intersection of these two from 1 and 2. X belongs to intersection. Let me just call this set A and this one B. Then x has to lie, because x has to satisfy both conditions 1 and 2. So x has to lie in the intersection of A and B. And the intersection of A and B is let's see where these intervals are. A was from minus infinity to minus root 2. This is it. Root 2 is 1.414. You can check this. And e to the power 4 plus 1. You don't even have to need, you don't need to check this. 2 is anyway greater than e to the power 4. E to the power 4 plus 1 is greater than 2. So square root of 2 is also, right? So square root of 2 is less than square root of e to the power 4 plus 1. That means you have square, if this is 0, then your square root of 2 is here and square root of e to the power 4 plus 1 is here. Similarly, on this side, you will have minus root 2 and e to the power square root of e to the power 4 plus 1. Negative of this will be on this side, right? And you say that you have to take the intersection of these two from minus infinity to root 2, minus root 2, this one, and root 2 to infinity, this one. And then you have to intersect it with this red set, which is this one. Just 1 second. Our interval here was minus infinity to minus 2 for the first set and root 2 to infinity. And for this one, we had minus infinity to this number and this number to infinity, right? Okay. Okay. We also have to make sure, first thing is we have done, this is for domain, is this for domain of G? No, this is for domain for Gx being here, right? And this is also one of the intervals we have, right? For x squared to x squared, we have this too, right? This condition should also be satisfied. So there are 3 conditions on Let me just call this condition 1. I want this to be satisfied for my domain. Then this is the second condition I want to be satisfied. And this is the third one. So that means I have minus infinity to minus 1. Minus 1 is here. We have minus 1 here. Minus infinity to minus 1. Just 1 second. Let me just check the entire solution again. So this is we want 2 to be less than x square. So your x should be, wait. X square minus 2 greater than 0. This will like be x minus root 2, x plus root 2.
It is okay, ma'am. Like you have written x less than x square. So x square minus 2 will be less than 0 here. So what you have got the result that is right actually. But here that is less than 0. We have to write.
Just 1 second. If you have x greater than 2, you have x square greater than, sorry, x greater than root 2, you will have x square greater than root 2, right? This one, I think this one is fine. So this domain, for this one, your x is correct, right? This B set is correct. What other set did we have? This one, right? You wanted x square to be less than e to the power, okay. Here we have the opposite thing, right? We have made a mistake here. Maybe you have x between this. Okay, we were taking a wrong set the entire time. I got it. Our A set is, I was taking it from minus infinity to this one. Okay. So this is again here, let's say if you have minus infinity here, and this is minus square root of 2. What else do we have? We have minus square root of e to the power 4 plus 1. Then 0 here, root 2 here, e to the power square root of e to the power 4 plus 1 here, and infinity here, right? So our first set, A set was, if this A set is from minus e to the power minus this quantity, this one not included, to this one, right? This is our A set. And then the B set that we have taken is from minus infinity to minus root 2. So it's this. And from my root 2 to plus infinity, this one, right? And then we have another thing too, which is from minus infinity to minus 1. We have another condition, which is from minus infinity to minus 1. Your minus 1 will be somewhat here. Minus 1, here you will have 1. So it's from minus infinity, from here to here. And this one will be from here to here. So you have to take the intersection of, you have to take the sections where we have all blue, green, and red, all of these, right? So we only have blue, green, and red here from this one, from minus root e to the power 4 plus 1 to minus root 2 in this interval where these two are not included, because root 2 was not included here, right? In this interval, your root 2 is excluded. Here also, here minus root 2 is excluded, root 2 is excluded. Here e to the power, this square root, this quantity is excluded, this quantity is also excluded. So this intersection of these three colors is going to give you this, and this one is going to give you union square root of 2, square root of e to the power 4 plus 1. This should be the answer then. And it's option A. Is this okay?
Yes.
Can we move to the next question? So, just 1 second. This So the next question is this one. Right. So give this question a try. This one.
Excuse me, ma'am.
Yes.
Ma'am, what are the answers?
The answer is 10.
X equal to 10. Huh.
Yeah. Okay.
Yes, ma'am.
So we'll do this here then. So this is, you have to find the solution of this, the x, the value of x, such that it satisfies this equation, and that x should lie in the domain of this. So let's just say this is condition 1, that x should satisfy this equation. This is condition 2, that x should be in the domain of this one, right? So starting with the first one, let's find the solutions of this equation first. You have log base 2, x minus 2, and here you have log x minus 2 base, and this is 64, so I can write this as 2 to the power 6. And I can take the 6 out. So this will give me this thing, right? And then I can, because I know I want the base to be same. So what I'll do here is, if I want to solve this equation, what my intention is, I want to put this as t or something, so I can solve it and then I can find the value of x. Once I know the value of this expression, I can find the value of x as well. So my first instinct here is that we need to find the value of this one, this entire thing. So we're substituting. Instead of having this, let's just have both of these same. So you'll have log base 2 x minus 2, and this I can write as 6 by log base 2 x minus 2. So that we have both of these things same. I can substitute this and this, both of these expressions, as t. I can put them equal to t. So this will give me t plus 6 by t is equals to 5. And if we solve this one, we'll have t square minus 5t plus 6 is equals to 0. And the solution to this, just 1 second. So the values of t that you'll get from here are, this is t minus 2 and t minus 3, right? So you will get t is equals to 2 and t is equals to 3. Or I should write this, either t is 2 or t is 3, right? So we have the value of t, that means we have the value of log base 2 x minus 2, which is equals to 2 or 3. That means the value of x minus 2 is 2 to the power 2 or 2 to the power 3, right? This means your x is either 2 to the power 2, 4, plus 2, 6, or 10. So the values of x are either it's 6 or it's 10. So these are the solutions for the first one. So we wanted to find x such that it satisfies this equation. So this, from here we get x can be either 6 or it can be 10. We have to check which of these two satisfy this one. So one thing that you can do is, you don't have to find although we'll do how to find the domain of this as well, but to make the question easier, it's better to just put it here, right? If I'll put 6 here, let me just substitute x is equal to 6. I'll have 6 plus 1, 7. Okay, then we don't even know if it's negative or okay. Let's try to do it without finding the domain of this. Let's see if we can do it or not. If I'll put x is equal to 6 in this expression, I'll have log base 3, 7 by 1. So this is the log base 3, 7. And because 7 is, if you have seen the graph of log base 3 function, it's this, where this point is 1, 0. That means, and you have 7 here, right? That means the value of x is 7 here. So if you will have, this point is somewhat here, that means this value is positive. In fact, it is, okay, for this, we'll need to make sure that it's great. This value is greater than 0. How do we know this? Because at 7, the value is this. This is log base 3, 7, and it's clearly greater than 0. Y is equals to 0 is this here, and you have this value. That means it's greater than 0. And then you will apply log half to log base 3 and Now we don't know this value, right? So that will be a problem. Okay. We have an extra log here, which is creating the problem. Otherwise, so let's not use this approach. That means we'll have to find the domain. Let's find the domain of this function. The function is let's log base half. Then we had log base 3, square root, and the expression here was x plus 1 and x minus 5. Right? So we have to find the domain of this. If this is f, we have to find domain of f. So to find the domain of f, first thing is we need to make sure that we start from the innermost function. This one is the innermost function, right? Then we have applied, this is the innermost thing. Then we have applied log to it, log base 3. Then we have applied log base half to it. And then we have applied square root to it. That means the innermost function is this. So first thing we need to make sure is for this thing, we want first x plus 1 by x minus 5 to be greater than 0, right? This expression should be greater than 0. Then second condition is, so you have to find x such that this expression is greater than 0. Then you have to find x such that log base 3 x plus 1 by x minus 5 is greater than 0. And then lastly, you have to find x such that this entire expression log base half, then log base 3, then this thing, this should be greater than 0. So you have 3 conditions to solve for here. Let's start with the first one. If you have x plus 1 greater than this greater than 0, that means either both of these expressions, this numerator and denominator, either both are greater than 0 or either both are less than 0, right? So you'll have x plus 1 greater than 0, you'll have x greater than minus 1 and x greater than 5, right? And for both less than 0, you'll have x less than minus 1 and x less than 5. So this thing will be, simply you can have x greater than 5 and x less than minus 1, right? So this will be x belongs to we've done this right? This is minus infinity to, we want it to be
Minus
less than
1.
this, so minus 1 and then union 5 to infinity, right? And this is for the first one, first condition, we get this. Then using the second condition, we'll have we want log base 3 x plus 1 by x minus 5 to be greater than 0. So this means this is equivalent to saying that we want x plus 1 by x minus 5 to be greater than 3 to the power 0, which is 1. So we want this thing. Now, one thing I want you to avoid is don't multiply both sides of the inequality with x minus 5 because we don't know the sign of x minus 5. So either you'll have to assume that x minus 5 is greater than 0, and then you can multiply both sides with x minus 5. So you'll have x minus 5, this thing. Let's do it this way. So you'll have if x minus 5 is greater than 0, so because this is a positive denominator now, so I can multiply with a positive number on both sides. So I'll get x plus 1 is greater than x minus 5. So this will be, you will have nothing from here, right? So this is no solution from here. And then if x minus 5 is less than 0, this will become x plus 1. If I'll multiply x minus 5 on both sides of this inequality, I'll get x plus 1 less than x minus 5, right? Because it's a negative number. I have assumed x minus 5 to be a negative number. So if I'll multiply it on both sides, the inequality is going to change. So this will then give me, okay, that's also incorrect. That means this approach is not working, right?
Ma'am, 1 can we bring on one side and
Yeah,
then we'll try to solve.
But why is this not working? This should be fine, right?
Ma'am, it's working, ma'am.
It is x plus 1. If I take x minus 5 to be greater than 0, I'll have x plus 1 greater than x minus 5, right? And then x gets cancelled from both
Ma'am,
sides.
one
That,
is
yeah, what?
ma'am, 1 is greater than -5, so it's correct. So x greater than 5 would be the
Okay.
condition.
So, okay, because that can be a little confusing. Let's not do it by that way. Yeah, if you'll take x plus 1 and x minus 5, then your x will get cancelled from both sides. And because 1 is greater than -5, which should mean that your x plus 1, the initial condition that we assumed x minus 5 greater than 0 was correct because you've gotten something correct.
Yes,
But
ma'am.
because it's a little confusing, let's not use that. Let's use the usual approach, which is x plus 1, x minus 5. So to avoid the sign involving the sign of the denominator, let's take -1 on this side. You'll have this. This will be x plus 1. Here you will have minus x minus 5 by x minus 5, and you want this to be greater than 0. So if we'll do this, we'll get 6 by x minus 5, right? So we want this thing to be greater than 0. That means we want x minus 5 to be greater than 0. We're getting the same thing that we got from there. But let's do this way. X minus 5 greater than 0, which means x is greater than 5. So from here, we have gotten a condition on x, which is x should be greater than 5. Then let's solve the third one, which is log base half, log base 3, and this expression, right? X plus 1, x minus 5. This should be greater than 0. That means for this one, you would want log base 3, x plus 1 by x minus 5 to be greater than half to the power 0. So it will be, and because we're raising it to the power half, because this is half this time and we've discussed this thing, so your signs are going to get changed. This will be half to the power 0, so 1 here. This inequality will change because your base here is half. Then next we'll have x plus 1 by x minus 5 less than 3 to the power 1. So you'll have 3 here. Inequality won't change because you have 3 here, number greater than 1. And then if you will solve this, you'll have x plus 1 minus 3 times x minus 5 by x minus 5. Right. So this should be less than 0. And this will give us minus 2x plus 16 by x minus 5, right? We want this to be less than 0. And just 1 second, we want this thing is in the square root, right? So we should want this thing to be greater than equal to 0. Why? Because if you have square root of x, then I want x to be greater than equals to 0, right? Whatever is in the square root, I want that thing to be, that can be greater than equals to 0. But if instead I have log and then x, then I want x to be strictly greater than 0. So for the first two conditions, I want this expression to be strictly greater than 0, then this expression to be strictly greater than 0. These two expressions should be strictly greater than 0, and this can be equal to 0 as well. That's fine. We can have 0 here, right? You can have 0 in the square root. So you'll have this thing, and so this is going to give us the upper one. The upper solution gives us x is equals to 8, and the lower one gives us x is equals to 5, right? This one and this one. So using the same approach that we've used, the signs, considering the sign of both of these, I think this is going to be in the interval minus infinity to we had 5 and 8, right?
5.
5 and then 5 to infinity, 8 to infinity.
No, ma'am, 8 to infinity. Yes.
We've used the same approach. Either both of these expressions should be less. So either this less than 0, we use this approach. Either it's positive in numerator, denominator negative, or negative here and positive here. And then we've solved for it, solved for x. So we'll be getting this thing only. Okay. So the third condition is this, that your x should belong to this, right? So, and wait, because we have equal to here, right? We have an equal to sign here. So I think 5 should be included and 8 should be included as well. Because we have equal to here. That's why.
No, ma'am, 5 will not be included.
Okay, 5's in the denominator, right?
Yes, ma'am.
Yeah. This is the, so what 8 should be included. 8's included.
Yes, ma'am. So the final inequality will be 8 to infinity.
Right. So because this is from condition 3. So let's just write all of these, right? From condition 1 we had, just 1 second. Where are the conditions? From here we had x belongs to minus infinity to 5 and union 8 to infinity, right? So from first condition we had, what was the interval there? X greater than 5, right? No, this was minus infinity to minus 1 and 5 to infinity. The second one gave us this x greater than 5. So it is 5 to infinity. And the third one gave us this minus infinity to 5 and 8 to infinity. So if you'll take the intersection of all of these, and our roots were, we just need to make sure that x
600,
satisfy all
600.
these 3 conditions. So x was either 6 or 10, right? So if we'll check 6, 6 is not, okay, it's here. It's here as well. It's not here, right? Not in this one. So because x is equals to 6 does not satisfy the third condition, this one, that's why it's incorrect. Let's check for the 10 one. It's in this interval. So third condition is satisfied. Second is also satisfied. First is also satisfied. Because x is equals to 10 lies in all these intervals. That's why this should be the correct option, the correct answer. So your x should be equal to 10. Because it belongs to 1 intersection 2 intersection 3. Okay. So the answer, there were no options, right? So the answer is 10. Can we move to the next question if this one's fine?
Yes, ma'am.
So the next question is this one. What should be the graph of e to the power mod x out of the options given? So your e to the power x graph looks like this. If you have fx is equals to this, it looks like this. It's an increasing function. But if I'll take e to the power mod x instead, that means for positive values of x, this is e to the power x when x is greater than 0. And when x is less than 0, this is equals to e to the power minus x, right? So that means, and this is e to the power x curve, this is e to the power minus x curve. This is e to the power minus x. So this says for x greater than 0, Your curve is e to the power x. That means this one. And for x less than 0, your curve is this one. That means your curve should be the red one, the one that we've marked with red. So the correct option should be this one. Looks like the correct one. Is this okay? Can we move to the next question if this one is clear?
Yes, ma'am.
Okay. So the next question is, this one. Give this question a try. Anyone done with the question?
Ma'am, it should be, is it a MSQ or a single answer correct?
That shouldn't matter though, but it's an MSQ.
Then it should be A and B.
Why do you need to know if it's an MSQ or not? Okay, let's see.
Because I got two correct answers. Because I feel like two answers are correct.
Yeah, if two are correct, then it's either it cannot be an MCQ or okay. You just have to find if whether each statement is true or false. It shouldn't matter whether it's an MCQ or MSQ. Okay, let's
Oh,
see.
okay.
Right. That's what MCQ and MSQs are for. Check whether each statement is correct or not. So let's test these.
So first
The
two should
first,
be true.
first one is true. And before getting into the options, let's do one thing. Let's say if you have a function f and it is composed with another function g. If this is my composition fog, then if g is 1, 1 and f is also 1, 1, this implies GOF if it exists. Provided GOF exists and FOG exists, both are 1, 1 functions on their respective domains. So if G is 1, 1, F is 1, 1, then GOF and FOG both are 1, 1 functions. That's one thing. And the same goes for onto functions. So if G is onto and F is also onto, if both of these are onto functions, then the composition is also an onto function. That's one thing. Then second is, let's say you have FOG and I say G is an increasing function and F is also an increasing function. Then what can I say about this FOG, the composition?
It is also inclusive.
That's
It
also
will be
increasing.
strictly increasing.
Yeah, if F and G are strictly increasing, then you can say that FOG is strictly increasing. But at least we can say that FOG is increasing in this case, right? Now, if I have G increasing and F decreasing, what then? And when I have G decreasing, F increasing, and then finally, let's take G decreasing and F decreasing. If FOG is, if G is a decreasing, increasing function, so let's do this from here. If X, let's say X1 is less than X2 and G is an increasing function, this implies GX1 is less than gx2, right? Less than equals to at least. These two are true. Now, if I take them to be different, if they are different, then it's fine. If they're not different, then if gx1 and gx2 are same, because I've taken it, let's ignore this one because this is making things complicated. So gx1 is less than gx2, right? And I know because g is an increasing function, that's why we haven't changed the order of the inequality, the sign of the inequality. Then we'll apply f, and f is a decreasing function. So if I apply, if g, that's the definition of decreasing functions, right? If gx1, gx2 is less than gx2, then f of gx1 should be greater than f of gx2, right? So that means and this I can write as fog of x1 greater than fog of x2. So I started with x1 less than x2 and I ended up with fog of x1 greater than fog of x2. The inequality has changed here. That means your fog is a decreasing function, right? So it's decreasing. And you can do the same thing here. The same applies here. You can try it in a similar manner and you will see that this is also a decreasing function. So if g decreases first, you will have x1, x2 in this order. Then g's sign will change and g will change the sign of inequality and f won't change the sign of inequality because f is increasing, right? So you will have for x1 less than x2, you will end up with fog of x1 greater than fog of x2. So it's the same thing here. You will have fog decreasing. And in this one, you will have fog decreasing, right? Both of them are decreasing. So the composition is also decreasing. Is that okay?
Yeah.
So that now come to the question. We have this function where, and log is when no base is given. When this is given, it's base e. When simply log is given, then it's base 10. So this is base 10. This is also base 10. So log with base 10 is an increasing function, right? Log base 10 is an increasing function. X is, by the way, x is also an increasing function. And again, you have composed it with log base 10. So all three of them, if you will consider them three, otherwise you can consider them just two functions, right? So log base 10 and composed with log base 10, both of them are increasing. That means this composition is also an increasing function. So this C is definitely incorrect. See, this f is not a decreasing function. Then coming to D option, the domain of f is 0 to infinity. How do you find the domain? First, you have to make sure that your this x is greater than 0. And then you have to make sure that log of x is greater than 0, right? So this will give you 0 to infinity. And this interval will give you x greater than 1, right? This will be 1 to infinity. And if you will take the intersection of these two, you will get 1 to infinity. So that means your domain is 1 to infinity, not 0 to infinity. This option is also incorrect. Now let's come to the first and second. Because both of these, you have composed log base 10 with log base 10 function, right? You have composed these two functions. And because both of these are 1, 1 functions, they're same functions, composed two times. And log base 10 is log is a 1, 1 function. I think we've discussed this thing. Log of x, no matter what base you take, log base ax is a 1, 1 function. That means this composed two times should also be a 1, 1 function. So it's correct. Then let's come to onto. We have discussed this for onto as well, right? That if both of these are onto functions, which is true, your log base 10 looks, log base 10 or log any base greater than 0 looks like this. And this is definitely an onto function because you're covering from minus infinity, y from minus infinity to y till plus infinity, right? You're covering every number on this line, right? Every y is attainable. That means your function is an onto function, right? This is not an onto function. If I'll take this thing, this is not onto because this part, negative y-axis is not covered. No value is on the negative y-axis. That's why this is not an onto function. But the one that we've made here, this one, this is an onto function. That means this is an onto function. This is an onto function. Both of these are onto function. That means the composition is also an onto function. So this is also true. That means your function is function is 1, 1, and it's also onto. And 1, 1 onto means if a function is both 1, 1 and onto, that means it's bijective. That means the inverse exists, right? So this is also correct. So both these options are correct. Can we move to the next question if this one's clear? Is the question that we've just discussed clear to you all?
Yes, ma'am.
Okay, can we move to the next question then? Okay, we'll do the next one. This is the next question. So which one of these do you think is correct? Let's do this one here. So
I think
the
A and
function
C.
is, okay. The function given to you is log of this thing, right? Mod of log of x plus 1. So first is you have to find the domain of this. The only thing that will trouble you is this thing. You just need to make sure that x plus 1 is greater than 0. That means your x is greater than minus infinity. So it should be from minus 1. So it should be from minus, this is greater than minus 1. So it's minus 1 to infinity, right? So this option is correct. First thing. Then because this is correct, this has to be incorrect. And coming to this one, whether it's 1, 1 or not on the interval, this, you have to find whether this function is 1, 1 or not on this interval minus 1 to 1. I know that my log function is 1, 1, but the only problem, the log function is 1, 1, right? But the problem will be this mod function. This mod function is not 1, 1. This is a composition of two functions. One function is log of mod x plus 1 and the other function is mod x. This is f, this is g, then the function given to you is fog, right? So this g is 1, 1. There's no problem there. But mod x, this function, this mod 1 is not 1, 1. And where is, let's just check where is our mod function. When is our mod function 1, 1? We have, in what domain do we have mod x 1, 1? If I say mod x is 1, 1 on domain A, let's say there is some domain A that I've decided for mod x function, then what can A be? Can I take A to be from minus 1 to 1? Or can I take it from minus 1 to minus 10 to 10? 10
No,
to minus
it has
10
to
to
be from
20, right? So you just need to make sure that there are no negative. If I'll make sure your A can be either A is a subset of minus infinity to 0 or A is a subset of 0 to infinity, right? A has to belong to either of these two sets. A has to be contained in either of these two sets. If A is contained here, then that means mod x is 1, 1. If A is contained in this set, that also means that A is 1, 1, right? Now, if I say, I'm saying mod of log of x plus 1 is 1, 1, right? Then where will this be 1, 1? I know that mod of x is 1, 1 on. That means I want either this interior to be greater than 0. This implies either your log of x plus 1 should be greater than 0, right? If you want mod x to be 1, 1, then I need to make sure that in my domain, all the x's, if this is 1, 1, then I need to make sure that x is either greater than 0 or x is less than 0. That means either on this domain it's 1, 1, or on this domain it's 1, 1. That means this function is 1, 1 either on this domain where log of x plus 1 is greater than 0, or it's 1, 1 when log of x plus 1 is less than 0, right? Is this much clear?
Yes, ma'am.
Okay, so that means now this is never possible if you see this. Okay, your log of this is also negative, right? Okay, let's solve this one then. So if you have log of x plus 1 greater than 0, what do we get from here? You will get x plus 1
X should
greater
be
than,
greater than -1.
this will be greater than 1, right? So this will, 1 second.
X should be greater
You
than
will have
-1.
x, this condition is just 1
Yeah, yes,
second.
yes,
You
yes,
will
ma'am. Yes,
have
ma'am. It should
10
be
to the
greater than
power
0.
0 here. So this will be x greater than 0, right?
Yeah, yes, exactly. Yes, correct.
So either you would want, now what do I want? If I want this to be 1, 1, if I say this is 1, 1, then I want either log of x plus 1 to be greater than 0, or I want log of x plus 1 to be less than 0. Now both of these should not simultaneously hold. It's or. And when I say or, I can't go on like, okay, it can be this or this. Both of them are fine. That's not true. Either this is this or it's this. That means if this is true, this should not be true, right? That's what we were doing in mod x as well. When we discussed mod x is 1, 1, we said either you should take x greater than 0 in that domain, this is 1, 1, or you should take x less than 0 in that domain, it's 1, 1. If you mix these domains, it will not be 1, 1, right? So this is x greater than 0, and from here you will have x less than 0, right? So what do I get? So the conclusion that I get is this: log of x plus 1 mod is 1, 1. On x such that x greater than 0, or x such that x less than 0, right? So I should be taking one of these. That means either my domain, if I'm taking some domain for mod of log of this thing, then I should make sure that domain should lie in this interval, in this set only, or in this set. It should not be in both of these sets, right? But what's given to us is we have been given -1 to 1, right? If this is the domain, if I take the domain for this function to be this, if this is f, and if I'm taking, if domain of f is this, then -1 to 1, this interval lies in both these sets, right? In this one too, and in this one too. That means it's not 1, 1. Is that okay? -1 to 1 lies some elements in this. It does not completely lie here. It does not belong to any of these sets, but some x in this one lie here and some x in this one lie here. That's the problem. Or in simple words, if this is too much, this is how you literally prove this. But if you don't want to go by this approach, what you can do is you can test for numbers. You can test for numbers between if you can find numbers between -1 and 1, for which this function gives the same value, two numbers in this interval, which give you the same value, that means it's not 1, 1, right? So those two numbers can be, if I'll have,
Excuse me, ma'am. Can you draw the
yeah,
graph? Can you draw graph? I think by that it will be very much clear. If you rough graph you can draw. If we can sketch the graph of this.
okay. The function is, first you have log of x plus 1. How do you draw the function? The function for log of x plus 1 is, log x is this, right? Log x function is this, where this point is 1, 0. Now if I have to draw the graph for y is equals to log of x plus 1, it will be, if I'll put x is equals to, y equals to 0, this point will change, right? So this point gets shifted to, because you have x of -1. So this gets shifted -1 units to the right. That means 1 unit to the left. So you will have this here. Is that okay? So this is the
Now
graph
we
for
yeah.
log of x plus 1. But we have mod of log of x plus 1, right? So the graph for mod of log of x plus 1 will be, how do you find this? Where does this become, where does this thing become 0? Log of x plus 1 becomes 0 at 0, right? If I'll take x is equals to 0, my log of x plus 1 will also become 0. So at x is equals to 0, this becomes 0. That means for x greater than 0, this entire thing, x plus 1 is also greater than 0, and log of x plus 1 is also greater than 0. In fact, this is greater than 1. If x plus 1 is greater than 1, let's do it this way. If you have, here you have x plus 1,
Ma'am,
which is greater than 1, right?
total mod, we draw the reflection along y-axis, something like that we used to do, I think
Yeah.
so.
But you need to, you draw it about this one, then you have the that's what we're doing when you have 0, 0. If you had some other thing here, let's say if this thing, if instead of this, I take x minus 1, if I take log of x minus 1, then my graph does not shift here, right? It shifts this graph shifts on this one to 0, right? So it will become like this. So now I won't be taking reflection about this axis. I'll be taking reflection about this one, right? This is x is equals to 2. So I'll be taking reflection of this one. So after this, your graph will remain same. If you have to take log x minus 1, this thing will be, this upper one remains same. This one changes. You had this thing here, right? This becomes this. Right? If you had just 1 second. You initially had your graph, this was log of x minus 1, right? Where at this point, after x is equals to 1, this value is positive. Before x is equals to 1, you had negative values, right? Now, if I'll take x greater than 1, I'll have log of x minus 1 greater than 0. That means my mod of log of x minus 1 will remain greater than, this will remain log of x minus 1. Is that okay?
Yes, ma'am.
Let's do this again. If your x is greater than 1, that means your log of x minus 1 is greater than 0. Now, if I have some argument in mod function, then when is this thing? I know that mod of x is the same as x when x is greater than 0, right? That's what we've done here. Mod of this thing is equal to this same thing without mod, because when this is greater than 0, when this thing is greater than 0. And when is this thing greater than 0? When x is greater than 1, right? So this function is log x minus 1 when x is greater than 1, and minus of log of x minus 1 when x is less than 1, right? So this becomes, so after 1, this is x is equals to, where is x is equals to 1? You'll
Before
have
this
this thing, 1 second. You have log of x minus 1. You'll have 2 here. 2 minus 1 is 1, which gives you 0. That means at 2, you'll have zeros. So the vertex, not what we don't call it vertex officially, but this 2 comma 0 is the point, required point, right? And you have log of x minus 1 when x is greater than 1. Should I have, wait 1 second. I think we've made a mistake here. This thing will be log of x minus 1 when log of x, okay, I see it now. We have mod of x is equals to x when x is greater than 0 and minus x when x is less than 0, right? So if I do mod of log of x minus 1, this will be log of x minus 1 when log of x minus 1 is greater than 0, right? And minus log of x minus 1 when log of x minus 1 is less than 0, right? When is log of x minus 1 greater than 0? When x minus 1 is greater than 1. And this is when x is greater than 2, right? And this is when x is less than 2. Is this okay? So that means for your x greater than 2, this mod function, mod of log of x minus 1 is the same as log of x minus 1. So for x greater than 2 here on this side, your function remains log of x minus 1. Mod of log of x minus 1 remains log of x minus 1. And on this side, when x is less than 2, this side, this function is, this one is log of x minus 1. So what will be if this is log of x minus 1? If this is log of x minus 1, then what should be minus of log of x minus 1? It should be this, right? This thing, this reflected here, right? This and this same thing, but taken with positive value, right? Is this
Yes,
okay?
ma'am.
That means you will have this here. This thing will go here. And this will be your log of, so this function now, this one, this red one is mod of log of x minus 1. Now coming to our question, we had mod of log of x plus 1. So our origin was 0, right? We had 0, 0 here. If I'll take the mod of this function, what will I get? I'll get this thing, right? Is this okay? I have shifted this branch to this other side.
Yes, ma'am.
What was the question? Yeah. So now the question
Thinking about the
was,
domain. Domain, we are saying that.
now you can clearly see where it's 1, 1, where it's not 1, 1, right? If you will take the domain to be minus 1 to 1, minus 1 to 1 is here. From graph, if you see your minus 1 is here, 1 is here, and it's clearly not, you're going to have same values, right? At this point and at this point. If I'll take this point and this point, approximately these 2 points, they'll give me the same value of y, right? So between minus 1 and 1, our function is not 1, 1. But if I'll take it from 0 to infinity, that's what I said there. If I'll take it from 0 to infinity, isn't my function 1, 1? This function is 1, 1 from 0 to infinity, right?
Yes, ma'am.
And it's also 1, 1 from minus infinity to 0. But if you start mixing points from here and here, then it won't be 1, 1 anymore. That's the problem. So coming to the options, this is not a 1, 1 function in this domain. And sorry, this one's correct, right? Not a 1, 1 function, and this is incorrect. Is this okay?
Yes, ma'am.
Yes, ma'am.
Okay. So then we have 2 more questions. Should we do those questions here, or let's do this one only because the time's already over. So let's do this one. We have this question. You have been given 3 functions and you have to check these options for it. So first is f of g of x is not an injective function in its domain. So your composition becomes, if you compose these things, you will have log of x square, and this is 2 log x squared, right? And the domain of this will be, so you will have here log of 4 log x square. You will have this thing, right? So this is your composition function FOG, and you will have to find the domain for it. So you can find the domain using the formula for composition of FOG. Now they're asking whether it's 1, 1 or not 1, 1. So what happens with log function is your log function looks like this, right? Now, if I'll take log of x square, or maybe I can have an example here where this is not 1. Just 1 second. Okay, so if I'll take let's say if I'll take log x, because log x can take both values, right? Both negative and positive. Log x can take all values, right? What's the range of log x? It's minus infinity to infinity. That means it can take all values. So let me just take this one, where log x takes, where log x value is -1. And let me just take 1x when log x is +1, right? I can find such x, right? Because the range of log of x is minus infinity to infinity. That means -1 and 1 both are in the range of log of x. Now that means log x can take -1 value and log x can also take 1 value. Now if it will take -1 value, then this will be -1 square times 4 and log of this thing, right? And if we'll take positive values, this 1 square. Now both of these are giving same values, right? And these are different. How do you know that these x are different? We know that if I'll take log x, let's find it from here. What will be x? Let's take this to a 10 base and 10 base. This will be x. X is 10 to the power -1, so which is 1 by 10. And here I'm taking x to be, this is 1, right? So this is 1 and this will give me 10. So if I'll take x is equals to 10 or x is equals to 1 by 10, or you can take any number. Let's take x is equals to 2 and x is equals to half. What's the value of FOG at 2? I'll have log 4 and just 1 second. If I'll take x is equals to 2, FOG at 2 will be log 4. This will be log 2 whole square. And if I'll take FOG of half, I'm taking x is equals to half. So I'll have log 4 log half square, right? And this is the same as, because this is half, I can write this as log 2 to the power -1 or this square, right? Or I can write this as, I can take -1 out. So I'll have this minus log of 2 squared. That means this quantity will be log 4 log 2 squared. Is this okay?
Yes, ma'am.
So that will mean that at 2 and at half, at different numbers, my FOG is giving the same value. This means this option is correct. It's not an injective function on its natural domain. And coming to this one, is are these two functions equal, f and g?
And like by log property, it is seeming to be same, but when we see the domain part, so for the fx, domain will be all reals, and for the
Yeah.
g, it will be greater than 0.
So for, yeah, correct. So first thing to notice, the domain of both of these functions is anyway different. Now, if you'll try, the expressions might be, your function composes of two things. First is the expression of your function, and the second one is your domain too, right? So if you'll change the domain, if I have, let's say, fx and, or let me just say this thing. If I have fx is equals to 2x, and here I'm taking the domain to be R, and I'm taking gx is equals to 2x, where I'm taking the domain to be 0 to infinity, then these two functions are different functions, right? They're different. And these two functions are considered, if you say that two functions are same, then that means your functions are also same and the domain of those functions is also same. You can put the same values. Here in this function, I can put x is equals to, I cannot put x is equals to -1, right? -1 is not in the domain of log. So log of, I say that f function is equal to g if fx is equals to gx for all the values of x in the domain of f and g both, right? Or okay, like the simplest approach that you go here is that the domain of, you don't even have to get into which value, which number is not working for this one and this one. You just have to see that the domain of both of these functions is different. That's why these two functions are different. Or in particular, if you want to check at x is equals to -1, the value of this function does not exist. This function does not exist at x -1. X is equals to -1, but this one exists at x is equals to -1. That is why these two functions are different functions. These functions are also considered different and the domain of these is also different. So the domain of f and g is not equal. You've been asked about function anyway. You're not, what's the domain of f is equals to all real numbers and domain of g is equals to 0 to infinity, right? Then fgx is an injective function. This is f and this is g. If I'll compose these two functions, we've already seen that it's not an injective function on its domain. This has to be incorrect, right? We have tested this in first option. Then the range of hx and gx are equal. Let's come to the range of hx. This is hx and this is gx. What's the range of hx? We know that log function can take, we've just discussed, log function can take both values. The graph of log looks like this. It can take both negative values and positive values. So that means 2 times log function can also take both negative values and positive values. That means your range of g has both negative and positive values, but your range of h will only have positive values. That's enough to conclude that the range of both of these is different. Is this okay?
Yes, ma'am.
Okay. So with this, we'll end the session. Does anyone have a doubt in the questions we've discussed so far?
No, ma'am.
Or some other particular doubt that you want to discuss? Can we end this session there then? Here then?
Yes, ma'am. Thank you,
Okay.
ma'am. Thank you, ma'am.
Okay, so we'll end the session here.
Thank you,
Thanks
ma'am.
for joining.